Today we're going to talk about the equation of a plane. Now, what is a plane? A plane is going to be a flat surface somewhere in space. In order to get an equation of a plane, we're going to need certain requirements. So, for example, as you can see here, we got 3 points, and those 3 points are defining this plane. There are different ways in which we are going to be able to define the plane. So first we're going to talk about how do we find the equation of the line with 3 points. Then what if we have one line and one given point? And then what if we have a vector that is normal or perpendicular to the plane? And some more information. So first, let's look at the equation using 3 points. So let's assume we have in space points A, B, and C. So here somewhere is the origin. Now this is a two-dimensional diagram, so it is a little bit harder to see. But if we have those 3 points and we know their coordinates, of course, they are going to form a plane. Now, the way that we're going to define the plane is by looking at possibly a similar structure to the line. For example, we can think of A as one starting point of my plane. So I'm going to call this vector A. But also, any other point in my plane should be a multiple of this vector AB. Let's call it AB. But also, if I do that, if I follow just a multiple of AB, what I'm going to be doing is forming a line that goes through A and B. So I have to be able to move outside of that line in order to generate any other point. So what I also should be able to do is I should be able to also move a multiple in the direction of AC. So let's call it AC vector. So with that in mind, similar to the equation of the line, here you can see how the setting of the 3 points would be. You would need for sure 1 point on the plane that we're calling A and 2 vectors AB and AC that are on the plane. The gray vectors that you can see in the animation are on the plane, and those are our vectors in green and in blue right here. Now, how do we build the equation of the plane? Well, the vector equation of the plane using 3 points is very simple. All you have to do is call it, let's call it pi as vector, and that would be vector A plus, we're saying multiples of AB, so let's call it mu AB, some parameter AB, plus I should be able to move outside of that line that I just formed, going in the direction of AC. So I'm going to add lambda times AC. Let's do an example. Find a vector equation of the plane containing the points M, N, and P. They are given right here. So a similar approach as we did in here, we, instead of having the points A, B, and C, we're going to have the points M, N, and P. So we are going to have M here, N probably somewhere here, and P somewhere here. It's really hard to visualize where each of those points are in 2 dimensions, but let's say they are right there. So what I want to do is find 2 vectors that will be on the plane. Now remember, 2 vectors that will be on the plane are vectors that go from one of those 2 points to another. So we can define 2 different vectors by taking the differences between the vectors that point to 2 pairs of points. So let's do that here. Let's say my vector A, that is a point on the plane, I'm going to call that M. And then I'm going to take the direction vectors on the plane are going to be MN and MP. So what I'm going to do is I'm going to say the origin is somewhere here. Vector M is going to be the vector on the plane, and then I am going to define my two direction vectors, one from M to N and one from M to P. And with that, MN, MP, and with that, I will define my equation of the plane. So let's do just that. So the vector MN vector is going to be the vector N minus the vector M. The vector N is, of course, the vector that goes from the origin to the point N. Yeah? So what is that? N is given. N is the point 1 minus 3. And the vector M is the point 3, 4, minus 2. That means the vector Mn is the vector minus 2, minus 5, minus 1. This is Mn. Similarly, let's find the vector MP. Vector MP is going to be the vector P minus vector M. Which is vector P? Vector P is the vector that goes from the origin all the way through to point P. So let's substitute. Vector P is also given. It is 5, 0, 2. And vector M is 3, 4, minus 2. So vector MP is the vector 5 minus 3 is 2, minus 4, and 4. We got our second vector right here. What does that mean for the equation of my plane? The equation of my plane that contains the points M, N, and P is going to be the vector pi equals vector M plus one parameter vector Mn plus another parameter vector MP. Let's substitute. So the equation of my plane is vector M 3, 4, minus 2 plus mu vector Mn minus 2, minus 5, minus 1 plus lambda 2 minus 4, 4. So this is the vector equation of the plane that contains the points M, N, and P.